Fucking freezing in here today, yo. Fucking freezing in here today. Bop, bop, bop. Sherry's Not Hondas and Kurt's Veen. How's it going, my friends? How's it going? You are the first ones in the chat. Infinite Gamer, how's it going? How's it going? I'm just checking my internet connection real quick because it seems a little bit slower than it did earlier. It seems a bit slower than it was yesterday and the day before. So this is whilst I'm streaming. Oh, hot damn! Hot damn, that's slow. Why is that so slow? I wonder if 3 have caught on to the fact that I am bypassing their cap. Afternoon to everyone. I seem to have dreadful internet issues at the minute. How does the stream look to everyone? Ah, Jesse managed to watch the explosion yesterday. Yeah, that was interesting. That was good fun. I've ordered parts for that one, so we'll see if that doesn't catch fire next time. The stream looks good, are you sure? OBS is telling me that I've got 458 dropped frames. And, well, if it looks good to you, then who am I to say that it's bad? Okay, stream health, let's have a look. Good, stream is healthy. Okay, alright, stream seems good, stream seems good. Interesting. Very interesting. Well, speed test is dead. I think that 3 might have caught on a little bit to my streaming antics because that is really slow. With the 4G I should be getting like 40 or 50 meg downloads. Very low speed. Here in Romania we have much better speed. Yeah, no, that speed is horrific. I'm at work. Please load these vids I'm missing, please. Yeah, sure, of course. With all the videos that I'm doing at the minute, sorry, yeah, some of the streams I'm doing most recently, I will download and edit them separately, and so that they're not quite as long, because all the streams at the moment seem to be like flipping 5 hours long, and no, ain't nobody got time for that. So it's still showing I've got 2.3 gigs left on my tethering. Okay. Alright, well, if the stream looks good to you guys, then I guess we shall get cracking with this one. So this video is going to be an interesting, slightly different format video. What I'm going to be doing is, before I started the live streams, before I started doing these live streams, I started work on an Atomic 7K. A lot of you will have heard of Atomic as a very good brand in car audio, and this is the 7,000 watt old school amplifier, really nice piece of kit. It's a basic board design, it's the Xenon, it's the same kind of shit, IRS 21844S, IRF 064N MOSFETs in the power supply. On the output section we have got I think it's oh, we've got actually something interesting on the outputs. We've got much better effects on the outputs than I've seen before. But because I started that video before I was starting to live stream, I've made up like about 40 minutes worth of the video, and I want to continue the repair on live stream. So what I'm going to do is I'm going to play you the first 40 minutes of the repair, which I did on video, which is all edited, so it's not any long crap waiting around for me to desolder stuff. And then in 40 minutes time, once that video has finished, I will continue with the repair live. And I haven't got much left to do on it, so if I hit play now on the video, hopefully it will stream alright, and yeah, it should look pretty good for you guys. Jesse says, I must say, some of the ladies at work heard your voice and love it. Oh wow, that's fantastic. That's very interesting. Jesse, let me know where you're from. I apologise if you already said. I can't remember if you said where you were from. If you're in the UK or the States. If you're in the States, I would understand that a little bit better, because it seems to be a thing with British accents in the States. I don't understand it myself, because I don't think the British accent's particularly great, and I don't even have a very strong British accent either. I have like quite a kind of Dartford local kind of accent. I wouldn't say it's like a kind of sexy British accent, but you guys can be the judge of that. So what I'm going to do is I am going to start the video for you, just to have a quick look at the live chat. Okay, wicked. How many viewers have we got so far? I'm just going to start the video. Yeah, 30 viewers. That's enough. Let's start with the main video, 40 minutes long, and then I shall continue the repair on live stream. See you in a bit. There, with reliability, yeah, it's not there. So although sorry guys, we're not getting any sound there. That's a piss take. It was showing that I had sound. All right, let's see if I can fix this. Yeah, for those of you who've just joined, I am live, but I'm going to be showing you the first 40 minutes of this repair that I've already done, because I started recording it before I started live streaming. Alright, let's try this again then. So let me know how this sounds. I'm going to unmute desktop audio, which means that I would have thought that would double up the sound and sound weird, but let me know if that fixes. Okay, yo, so this is a pretty big board we've got on the bench. This is a Atomic 7K. It's a pretty old amplifier, but it's one of the golden amplifiers. It's absolutely fantastic. Look at the size of this thing. So this isn't too dissimilar from the size of the Ground Zero 10K HC that I worked on before. You saw the video. We've got power supply's a little bit smaller, output section a little bit smaller, but in general it's the same basic circuit. Everything's laid out relatively nicely with a bit of good spacing, so the board has lots of thickness in the trace. The pads are nice and thick as well. We've got a good number of power supply capacitors and a good number of rail capacitors. Yeah, it's overall it's a really nicely designed amplifier. The board design is very old, as with all of these amplifiers from Korea. It's not a new board, so this amplifier does 7,000 watts, which is less than this modern Brazilian amplifier does. But the Brazilian technology, I don't believe, is quite there with reliability yet. It's not there. So although this uses much older FETs, 24N40Fs or 20N50s, it's a much older design, but it's much more reliable because these have been tweaked and perfected for years and years and years and years. So yeah, this should be more reliable. And well, saying that, we've got one in here for repair. We don't know why this one went down, but we have all the output FETs already removed by the owner, who was looking to see whether we could do a repair on this. But I decided to bring it in as it might be a little bit easier. We can change the drivers if we need to here with the hot air station. So first of all, we need to check that the power supply is okay, which I believe it is because the customer said that we've had that powered up before. But let's just double check anyway. So the easiest way to check the power supply is literally just to take your multimeter probes. Which way are we here? And put it on diode beep setting and put it on the power terminals. If you have numbers on the multimeter here which change, which should rise, so we've got minus number there, let's flip that over. So if your multimeter numbers rise here, which means we're charging the power supply capacitors, and that is a good thing. So that means we're charging all these capacitors here. So if the power supply was dead, usually we have a short across the pins 2 and 3 of these FETs on the output section, which means that we would have a direct short circuit across the power terminals, which we don't. So the power supply is probably okay. So now let's have a look at the output section over here. So just before we power it up, I want to make sure that there's no short circuits on the main rails. So we just go along all the pads here, and there is. We've got a 26 ohm resistance on one of the rails here, and it's possible that that is as a result of solder bridges. So when these FETs are removed, you can see there's a little bit of solder that remains on some of these pads. So before we go any further, what we're going to do is just take the iron. We're just going to go across every single pad of the output section to make sure that there's no solder bridges, because if there is, then that could cause a problem. We could then blow the power supply, or we could blow a regulation circuit. So that's what we're going to do first. Right, so I've gone through every pad, and it did look like there was a couple of solder bridges, so let's see whether that has disappeared, that resistance on there. Okay, no, we still have 25 ohms, and the 25 ohms is between the output and the ground of the output FET, so it's not on the gate. If we measure on the gate, we have a continuously charging value on the multimeter, so which is a little bit less common. I think there's quite a few issues here. We're going to need to put the driver board, and we're going to need to test all these values with the driver board out to see whether there is a capacitor or anything that's dead. Now, if we have a look on the board, do we see anything else that looks suspicious? Not sure how well you can see in there, but wow, this capacitor is definitely no more. So this looks like a smoothing capacitor for part of the low voltage supply that powers the drive circuit over here. So if we look over here, these here are some diodes, some rectifier diodes, and these come off of a separate wind on the transformers here. So these transformers, these two here, have additional winds that are shit. Crap. I accidentally hit one of my shortcut buttons. Ah, no! Crap. Alright, can we play this again without starting it all the way from the beginning again? I was trying to reply to Rob Land here in the comments, and I hit the exclamation mark, which put my was my shortcut for for camera 1. Oh man. Okay, let's try this again. I'm gonna actually open it in I'm going to open it in VLC Media Player so I can skip to where we were, because fuck watching all that shit again. Because I can't, when I play video on OBS, I can't skip to a position. You just have to play it from the beginning, so fuck that. So let's open it with OBS, sorry, let's open it with VLC, and let's skip to the part where we were at and continue from there.
Okay, yo, so this is a pretty big board we've got on the bench. It's
7K. It's a pretty old amplifier, but it's one of the golden amplifiers. It's absolutely fantastic. I mean, look at the size of this thing. Weird, that resistance on there. Okay, no. So this, do we see anything else that looks suspicious? Okay, I'm just lining up where it was before, and now I'm going to insert a video capture. Let's get rid of that one. Let's do window capture 2, VLC. There we go, VLC. And let's hit play, and that should work. Not sure how well you can see in there, but wow, this capacitor is definitely no more. So this looks like a smoothing capacitor for part of the low voltage supply that powers the drive circuit over here. So if we look over here, these here are some diodes, some rectifier diodes, and these come off of a separate wind on the transformers here. So these transformers, these two here, have additional winds that are on much thinner cable, and these come off and these go to these rectifier diodes rather than using the main rectifiers on the board. And these will supply the plus and minus 15 volts for the drive circuit. And the capacitors that are next to them are most likely part of the smoothing of the output of these rectifier diodes. So yeah, well, that needs to go. We need to replace that one, and that may or may not resolve our 25 ohm issue on the output. I doubt it will, because I don't think it's actually related to the output, so we'll need to find where that 25 ohm resistance is as well. It could be on the driver board. I'm just going to snap this cap off quickly and then suck the holes, and let's just see whether that resistance goes away once we get rid of the capacitor here. So what we're going to do is we're going to have to assume that it is the same value as the one directly next to it. I might have a look and see if there are any similar amplifiers that I've got in my to-do list on the in the pile, that I can see whether we can find out what that should be. But if it looks like it is just a smoothing capacitor, so it looks like there's a pair here and there's a pair here. It looks like it just goes off the other pair, so it's probably going to be the same value. So that is what is that? There's a 10 UF of 50 volt. Okay, cool. I'm sure we have a spare one of those on a donor board somewhere. So has removing the cap got rid of our 25 ohm resistor? No, it has not. So next thing we need to do is remove this driver board and find out where that 25 ohm resistance on the main rails is coming from. So that's 25 ohm resistance that we've still got between the pads here is on the side that the customer reported went down, that blue. So what's most likely to happen is it's absolutely annihilated the driver. So what we need to do is take the driver board out. I've covered this in previous videos, but I should do it again just because it's a good technique. So to get the driver boards out, what a lot of times happens is people that don't remove driver boards a lot, you end up pulling all the vias out, and it's like a real struggle. So many people that I speak to that want to give amplifier repair a go, the hardest part for them is removing the driver board, and they say it takes ages and they end up damaging the board. So just watch what I do here. This is the best way to get the driver board out without damaging the board or pulling any vias. So this solder will all be pretty old, so what we can do is we can apply some solder flux between the pads, which just helps the solder flow. So when we heat it up, it'll flow, this flux will flow into the holes, and it will help all the solder stick to itself rather than to the edges, and it will come up into the solder sucker nice and easy. So we're going to go along each of these. This is quite a big driver board. I think it uses 4 of the IRS 21844S driver chips. So once you've fluxed her up, take the iron. Now these don't have a high thermal mass, so you don't need to hold the iron on for very long at all. You shouldn't hold it on for too long, put too much heat into these traces. So just hold it on until you see it melt, and then suck her up. And all of the solder, I don't know how well the camera makes it out, has gone from that hole. And if we wiggle the driver board, you can see the leg wiggle in the hole, which means it's not even touching the sides. That's what the missus always says. So let's do the next one and just go along, repeat the process, suck the solder from each one of these holes. I've got my iron set to 370 degrees Celsius. It is an AOUA station though, so it's probably about as accurate as my shit, but that's what the number says on the screen, and so I know I'm used to what numbers, how they act. Whether it's actually 370 or not, I don't really care, as long as I know what different numbers do different things when I'm using it. That's all that's important to me. So once you've sucked all the solder from the holes, take the driver board over the other side, just give it a very gentle wiggle, and you'll see that some of the pins start to move in the holes, but some of them don't. The ones that don't move still have a little bit of solder that's connecting them to the side of the via on the board. So what you want to do is take the soldering iron and just nudge it away from the side and wobble the board so that until they become free in the hole. You want to go along and do this for each one of them so that every single one of these legs is free from the holes, and that way you don't pull out the vias which they're connected to when you try.
I'm having some fucking crazy issues with my internet today. Is it back up and running, guys? I have no idea at this point. Yeah, sorry guys for the interruption. There's some mad problems with my internet going on today. Literally, mad problems with my internet going on today. Let's see if I can get this back up and running. I wonder if 3 have caught on to the fact that I'm tethering outside of my my allowance. Alright, let's try this again. Sorry guys.
So sometimes you'll find one that still has a little bit too much solder left in the via, so heat it up, suck it again, and then you should find that it comes away very easily. So yeah, so all these lot here are now completely free from their holes. So you see they're all completely wobbly. So you just want to go along and do that for the rest of them. And the more you do, the freer and the easier to wobble you'll feel the driver board become. There we go. So now all of these legs are free in the holes, and you can see this is incredibly wobbly. It's literally requiring no force at all to wobble all these pins. So what we can do now is safely pull and wiggle gently on the driver